Hello students, welcome back into the another session of CS07 data structure using programming in C. After the successful completion of two units, that is introduction and sorting and searching, lastly we have started with unit number 3, that is introduction to data structure and elementary data structure concepts, where we have introduced the data structure in two different format, that is linear data structure and non-linear data structure. A concept like array, linked list, stack, queue comes into the linear type of data structure, where the arrangement of data should be into the proper structure using this concept called as a linear data structure. Non-linear data structure means, again it is a procedure of rearranging the data in a proper sequence, but it should be in format of tree, graph, etc., table or hashtag. This is called as non-linear data structure. Now apart from all this, first we have started with stack. So the definition of stack says that stack works in last in first out. That is called as LIFO. Stack use internal memory for storing the contents, or we can say that programmatically we can use one-dimensional array for storing the contents using the stack. But the thing is what? Say for example, I am adding the contents like this in array. Innermost content is 1, then 4, then 6, then 8 and then 9. At the time of insertion, it arranges like 1, then 4, then 6, then 8 and the last one is 9. So when I execute, that means whenever I fetch the value or deletes the value, first 9 should be deleted, then and then 8 will be deleted, then and then 6 will be deleted, then and then 4 will be deleted, and last 1 can be deleted. During the operation into the stack, two types of exception can be handled. That is an exception of overflow and the exception of underflow. The exception called overflow occurs when the total size of array, or we can say stack, exceed. Underflow occurs when none of the data available in stack still user deleting the data. At times the exception might occur, that is called as underflow. Based on these two exceptions, various operations that we have to implement into the stack are push, pop, pip, or we can say the update, and last one is display. So in previous lecture we have visited the algorithm for all these operations. Now it's time to discuss about the program of stack through which we can handle all such type of operations. So let's see how can we design that particular program. So the program for the same is like this. It's a little bit longer program, so I request all the students just to focus on each and every line which I speak. This program is of 192 lines. Day by day, these lines are going to be increased. So let's start with first the execution of program. Let's see how this program look alike. So whenever we run the program, there is our menu onto the screen. That menu contains 6 different choices, where choice number 1 is to push the data in stack. Number 2 is to pop the data from the stack. Third is pip. Fourth is update. Fifth is display. And sixth another is for exit. So all these are the operations of stack. One by one we have to perform. Let's start with the sequence. Right now this program is executed for the first time. So stack will be empty. We need to first insert the data. The limitation of my program is I can add maximum 5 individual numbers into the stack. That means this program works for 5 numbers which you can increase. I will show you into the code. So what I am doing is, first I am selecting a one choice, that is choice number 1 is push. So push operation will be executed. So on the screen there is a message, push operation is selected, enter value to be push. That means enter the value which you want to store inside the stack. So I am storing 3. So what will be the first value? That is 3. Press enter. Program will not going to be terminate. This is something new. Generally up to this particular code, whenever you press enter after entering the value, program get exited. But this program continues till you will not terminate the code. So again I am selecting choice number 1, that is push. So this is the second value. I am entering 7. So 3 is the first, 7 is the second value. Then the third one, suppose I am giving 9. Fourth one, suppose I am giving 4 itself. And fifth one, suppose I am giving 0. So once 0 has been given, it indicates that stack is overflow, because the size of the stack which I have predefined is 5. So if you still try to perform the operation of inserting the value, what it returns, stack is full. That 3 is not going to be added. So all the values is stored inside the stack. Let's display all these value. Okay, anyways, something some problem is there into the display. We'll see later on. No problem. We'll go for pop. Whenever we select the operation number 2, as per the theory of stack, whatever the last value is inserted by the push operation should be executed using the pop operation. So what will be the last value? That is 0. So 0 is deleted from the stack. Again suppose I select 2, next value is 4. Again I select 2, 9. Again I select 2, that is 7. Again I select 2, that is 3, and it shows that stack is underflow. That means there are no value now available into the stack for getting executed. Again still suppose I want to perform this operation, what it shows, stack is empty. That means my stack is blank. Again I am inserting two values. Say for example, I have added three values, 2, 6 and 3. Now what I am doing is I am selecting operation number 3, which is an operation of pip. Here I have to give the location on which I want to pip the value. How many location has been created? 0, 1 and 2. Total 3 values I have inserted. By default, first value is going to be stored inside the 0th location, then 1 and then 2. Here I am giving location number 1. So what will be the value over the location number 1? That is 3. So you can see that 0 contains 2, 6 contains 1, 1, 0, 1 and 2. So value 3 is executed onto the screen. Option number 4 is update. That is for changing the value. Suppose I am giving location number 1, enter the location of value which you want to update. Suppose I am giving 1, it shows this is possible. And suppose I am replacing that value with newer value, that is called as 9. So 9 is replaced as a newer value inside the stack. As in a stack, older value is 3 and the newer value is 9. So in this way, I can perform a various operation of stack. Suppose I press 6, then and then program will get exited. Now let's check why our display is not working. So for that I have to go for checking step by step. Here I will enter choice number 5, press enter, less than 1 and greater than 6. Okay, display selected, display, stack values, top of the stack, I is equal to toss, I greater than equals to 0, I minus minus. So this is not going to be executed. Why? Let's see. Let me enter some values first. I have inserted value 2. Let's rerun it again. We have to be very patient for this program as it's a very long program. 2 I have inserted. Now I am selecting display. Press enter. Display selected, display function is called, this stack values are fine, everything is proper. Okay, got it. It's displaying over here. So what we have to do is, let's rerun the code. Everything is proper, just a one simple mistake over there. Suppose I am selecting operation number 1 and entering the values like this, 9 and 0. I have inserted 3 values and I am selecting operation number 5. Anyways, leave it, no problem. No need to waste the time for this because this code is very long. We have to learn one by one. So let's start with the logical part of the code. Here first I have written the 2 necessary library function. Then I have defined the size of array, that is 5. Suppose over here I make a change from 5 to 10. In my stack I can store 10 values. Then 3 global variables I have declared, that is integer stack size integer top of the stack is equals to -1 and flag equals to 0. See, this stack is for holding the value of entered elements. Top of the stack is the internal pointer, which is by default set as -1. Whenever we increase, it is set as it's set on a position called 0. That means -1 plus 1 is equals to 0. We'll see this logic later on. Then flag equals to 0. Then there is an function declaration like void push integer x, void display, void pop, void integer pip and integer update. That means all these functions are of function without argument with return value and function without argument without return value. I think instead of looking the code in this Turbo C editor, we'll better go inside the notepad. So visibility should be proper. Let me open this code into the notepad and let me revise the everything again for the second time. Okay, this is the code. What I have done, first I have written the two necessary library function. Then I have defined a one variable called size with 5 as my limitation of array is 5. Then there is a stack of size which hold the user's inputted value. Then an internal variable which manages the top of the stack. By default it is set as a -1. Then flag is a temporary variable which is set as a 0. My first operation is a push operation which contains function with argument without return value. Again I am repeating my words. This function is of function with argument without return value. Second function is of display, which is of type called function without argument without return value. Third is a pop operation. Again this function is without argument without return value. Fourth operation is of pip. Again this was of function without argument with return value. And the last one is update, function without argument with return value. So all this UDF has been declared. Then there is a void main statement. Inside the bracket of void main statement, I have designed the menu. So for that, two variables I require, that is integer choice is equals to by default 1 and the data, and there is a while loop. While choice is greater than equals to 1 and choice is less than equals to 5, there is a do statement. Why I have written a loop over here? If you remember, then till I not select the exit option, program executes continuously. ગુજરાતીમાં હું કહીશ, જ્યાં સુધી હું એક્ઝિટ સિલેક્ટ નથી કરતો ત્યાં સુધી મારો પ્રોગ્રામ એઝ ઇટ ઇઝ ચાલુ રહે છે. એના માટે થઈને અહીંયા આપણે while loop લખેલી છે. Anyways, let's move on. So inside this do statement, there is an CLR SCR function, and the first line of the code is menu, which shows a menu onto the screen. Then the menu contains option number 1, that is called as push. Option number 2 is pop. Option number 3 is pip. Option number 4 is update. Option number 5 is display, and option number 6 is exit. Then there is one message that enter your choice. Whatever the choice user enters should be checked by this particular while loop. That means if user enters the choice like 7 or -1, program will be terminated. And apart from this, for 1 it select push, for 2 it select pop, for 3 it select pip, 4 update, and 5 display. And for 6 by default it exits the code. Now suppose over here user has entered the choice number 1. That choice is passed inside the switch statement. In C we have discussed about the switch statement. Switch statement is called as a multi-choice statement. So over here I have defined the various cases. Case number 1 is for the push operation. That means if I entered 1, case number 1 is selected, and inside the bracket of case number 1, what it indicates? Push operation selected. Then there is a message, enter a value to be pushed. That means enter the value which you want to insert inside the stack. That value is going to be read and stored inside the variable called data. Suppose my first value that I am inserting is 5. So that 5 is stored inside the data. And over here there is a function called which is called as push, and the value is passed called data. That means this is the function call. Over here the function call is done, and the name of function which I have created is push. So from this line program transfers in this section, and 5 is stored inside the variable called x. Over here one decision making statement is there which checks that top of the stack is empty or not. If it is empty, then automatically it sets the flag value as a 0. That means this value cannot be stored inside the stack. Otherwise, it increases the value of top of the stack. That means top of the stack is equals to top of the stack plus 1. That means the value is going to be push. Remember my last lecture, in that I have mentioned that operation of push always increase the value of top of the stack by 1. Pop operation decrease the value of top of the stack by 1. So here we are discussing about push operation. So top of the stack is increased by 1, and over that particular location the data that is called as 5 which I have passed from UDF is going to be stored, and the value of flag is going to be set as a 1. Because still the stack is empty, we can store any value inside this particular stack. Program repeats. Again there is a menu onto the screen. Again user selects the choice number 1. Now user has entered 0. Top of the stack will increase by 1. 0 is going to be stored. Again program repeats. Option number 1 is selected. Then the 3 is stored. Then 4 is stored. And then 5 is stored. Now what happens if I try to store 6, as it is a 6th value? 1, 2, 3, 4, 5 values are stored, and the limitation of my size is 5. I wish to store 6. What happens at that particular time? 6 is passed in this data. Push function is also called. Whenever the push function is called, this top of the stack, that means this decision making statement becomes true. The value of flag remains 0 as it is, and due to this it shows a message onto the screen that stack is full. And every time whenever the stack is ready to accept any value, every time whenever we insert the value, parallelly it calls the display function. That display function will display all the value which is stored inside the stack by repeating a one loop, that is for I is equals to top of the stack, I greater than equals to 0, I minus minus, and printf %d stack of I, that will display the value of stack which has been entered by the user. So this was an push operation of stack. Now once the stack is full, or once the stack contains the value, you can perform pop operation. અહીંયા એક આપણે સિમ્પલ ક્વેશ્ચન જે છે એ સોલ્વ કરી દઈએ કે માનો કે સ્ટેકની સાઇઝ જે છે એ 5 છે અને મેં 3 વેલ્યુઝ નાખી, તો શું હું પોપ ઓપરેશન કરી શકું? તો એનો આન્સર છે હા, તમે પોપ ઓપરેશન કરી શકો. એવું જરૂરી જરાય નથી કે સ્ટેકને ફૂલ કરી નાખો પછી જ પોપ ઓપરેશન થાય. આ પ્રોગ્રામ જ્યારે પણ તમે જાતે લખો, ચેક કરજો તમારા ઘરે કે તમે 2 વેલ્યુ નાખ્યા પછી પોપ ઓપરેશન કરો છો તો લાસ્ટ વેલ્યુ જે તમે નાખી હતી એ નીકળે છે કે નહીં. રાઈટ? સો લેટ્સ ગો અહેડ. નાઉ suppose I have entered the values like this in my stack 5, 4, 3, 0 and 1. Total there are 5 values, right? And now I am selecting an operation called pop, that is operation number 2. So obviously this choice contains the choice of case number 2. Case number 2 is written over here. In case number 2 there is a one intimation first, that is pop selected. Pop function is called. What is written inside the pop function? If top of the stack is equals to -1. What does it means? It means that the stack is empty and still you are trying to delete something, the flag becomes 0. Ultimately into the case number 2 I have written if top of the stack is if flag is equals to 0, then it shows stack is empty, and if top of the stack remains as it is, that is -1, then the stack is underflow. At that particular time display function is called, but don't worry, we'll discuss later on about this. Say for example right now the pop function is called. This decision making statement becomes false. Program goes inside the else statement. The last value will be displayed over the screen. As per our input, what will be the last value? That is 1. So 1 is going to be pop. So top of the stack will be decreased by 1. So inside the stack 1 is going to be removed, and program returns by setting the flag value is equals to 1. So again a main menu will be displayed onto the screen. Again suppose user selects the choice number 2, pop operation will be selected, case number 2 will be selected. It displays that pop operation is selected, value is going to be popped is 0. 0 will be decreased, 0 will be removed by performing top of the stack equals to top of the stack -1. Again user tries to remove, 3 will be gone, then 4 will be gone, 5 will be gone, and still user suppose select pop operation. At that particular time this decision making statement becomes true. It returns flag equals to 0. Flag equals to 0 shows stack is empty. Now we cannot remove anything, and even it shows stack is underflow, and it displays nothing onto the screen. So in my all operation display function remains the same while other function get changed. So this was all about a very most important 2 operation of stack, that is a stack that is the operation of push, and the operation of pop. I hope this is the sufficient dose for today's lecture, because I know this is very difficult to digest by sitting at a home in a simple small computer device, or we can say a mobile device, but we have no other choice. Stay home, be safe. In our next lecture we will go for another 2 option, that is called as an operation of peep and update, and after that I will give you the time for writing the entire program for your journal purpose. So till that, thank you very much students for listening me, and have a nice day. I request all the students just go through this lecture at least twice a day, because getting an idea of all these things is very difficult by sitting at a home, but still we have to follow all these instructions. So I request all the students just go through this lecture twice a day, so it would be very easy for you to understand the concept of stack with two options, that is called as push and pop. And in our next lecture we will go for another two options, that is called as peep and update, and then I will give you the time for writing the program. So till that, thank you very much students for listening me, and have a nice day.